Okay, so the mole is just like the dozen. So what does a dozen stand for in your mind? See? What does it stand for? 12. Right? It can be a dozen books, a dozen whatever. It's 12. The mole is just like that. It's a number. But it's a weirder number. It stands for a very, very large number. And what is that? Yes, 6.022. That's the number. It's called Avogadro's number. You've got to get it etched in your mind, okay? Avogadro's number is that large number. So when I say, how many books in a mole? And you will say, 6.022 times 10 to the 23. How many viruses in a mole? 6.022 times 10 to the 23. How many atoms of carbon in a mole? 6.022 times 10 to the 20. You get it? That's a mole. But that's a count, right? I'm not always interested in a count. What if I'm interested in the mass? How much does it weigh? Then what should I say? Well, there's another definition, and that is a mole also is the atomic mass in grams. So listen carefully. A mole is the atomic mass in grams. So how much does a mole of carbon weigh? Yes, you look at what? The mass, which is what? 12.011 grams. Is everybody understanding me? How much does a mole of silver weigh? 107.86 grams. This is where students have confusion. Wait a minute. You just said that a mole is 6.022 times 10 to the 23 for all of them, right? A mole of silver, a mole of carbon, a mole of boron, a mole of calcium have the same number of atoms. But they don't all weigh the same. Right? A mole of books wouldn't weigh the same as a mole of cotton, would it? It wouldn't. So they can have different masses. They just have the same number. Do you get it, folks? So a mole of silver will weigh 107.86 grams. Do you all get it? But a mole of carbon is going to be different because the atoms are different masses. Sure. The last problem on the test was about bauxite. 33. Oh, okay, 34. Sorry, I forgot to address it. A nickel atom is 28 protons, the cobalt atom is 27. Yes, the atomic mass of nickel is 58, whereas cobalt is 58.93. My question there was, even if they have different number of protons, their masses are similar. No, not quite the mole. It has to do with chapter 2, because they have the same number of neutrons. Because mass number is not just the number of protons, it is the number of protons plus the number of neutrons. So when you add up the number of protons and neutrons, you get the same mass number. Okay, so they have, you should actually, the answer is not that they have the same number of neutrons. The answer is that they have the number of neutrons that when added to the number of protons still comes up to. Huh? Oh. Yeah, it is recording. Yeah, it's recording everything. That's what I said. I'm trying to practice recording my lecture so that you will then tell me tomorrow on Monday whether you like the system. I'm trying to help in any way I can to make you do well in the class. But this may just, I may just fall on my face doing this. Keep learning first. Never done this before. Okay, folks. So did everybody follow? The question on this test had to do with number of neutrons. We're talking of moles. Slightly different things here. Okay. So I'm going to ask you two types of questions. I'm going to ask you I'm going to ask you for a count. I'm going to say how many atoms of carbon are in a mole of carbon, and you will say the count, 6.022 times 10 to the 23. If I say how many atoms of carbon are in half a mole of carbon, you will say, right, you will say 6.022 times 10 to the 23 divided by 2. Did everybody follow? How much does half a mole of boron weigh? 5-ish grams, do you agree? The 10.811 divided by 2. So you get the point, right? If you have the mole, you have the number of particles. It's like half a dozen. It doesn't always have 12, does it? Half a dozen will still be 6. Get it? Good. So if you got that, can you try these problems for me? And remember, I have to do it here. If I do it on the board, it won't record. Okay? So I want you to write these questions down, and then I will do it with you on this new page that I introduced you. Okay? Is that fair? Okay, so write down the first problem, and I can go even toggle. You don't have to copy all of them. Write down the first question in your book. Calculate the number of atoms in 1.7 moles of boron. For those, I forgot to mention what this is worth. For those who turned in your homework, because it's completely optional, I'm going to go over it. I want to still make sure you did it. I will add 8 points to your test. But that's only if you turn it in. Like I said, it's optional. You didn't have to do it. If you didn't, you receive an incentive. And you should have homework 1 to 1. Yes, ma'am, you should always do it. And I even told you, all right, I'm going to use it for extra credit on the test. You still didn't do it? He and I do things very good. Because he can just math with you. He says you know that in his life. That's what he said. All right, folks, did you write down the first question? Calculate the number of atoms in 1.7 moles of boron, right? I want you to attempt it, and then I'm going to do it. You did it, Jonah? I'm sorry? Oh, we did it? Oh my God, nobody even told me I've done all of them. Oh my God. Oh, well, did you want me to do it again? Oh, okay. Well, this is how, okay, did you attempt it already then? Okay, so we say 1.7 moles. I need a stylus terribly. 1.7 moles, right? And we said, okay, how do I do the problem? Tell me. What am I trying to find? The number of atoms. So I need what to go above? 6.022 times 10 to the 23. Okay, did everybody follow that? Yes, because we're trying to find the count, the number of atoms. See, and if it's a number of atoms, it will be a very large number. So, is this clear enough for today? You follow and doing this long and recorded, right? I'm going to find the stylus quickly. Okay, for him it works with his finger. I don't know. Maybe it's practice. So then you cancel the moles. Yes? And what should the final answer be? This times that big number there, correct? And what did you all get? The last time you all struggled with it. The answer should be with the right number of sig figs. You should only have 2 sig figs. Yes, it was like 1.0 should be the better way to report it. 1.0 times 10 to the 24. Everybody got that? Times 10 to the 24 atoms. Okay, that should be the correct answer. 1.0 times 10 to the 24. Okay. So what was the next? Oh, so let's go back to that list and do the last one. I want you all to do 4. Calculate the mass. Write down this question in your book, please. Calculate the mass of 5 million atoms. Yeah. That's how I like to write my 5 times 5 million. Because you know those zeros are trailing, aren't they? So why even write all those zeros? Just now you tell me. Tell me how I'm going to do this problem. What's the question asking for? Let's not forget the point. What are you trying to find? Math. Math, right? Correct, everybody? So, if I have atoms over here, obviously what should I put over here? Atoms, correct? Okay. So, how is it going to work if I put atoms over here and I need, yes, atoms on the bottom means I need to use Avogadro's number at the bottom. Does it make sense? Now the question is, how are you going to do it? Because I need to have grams on the top. Yes?
Well, I did Avogadro's number on the bottom.
Yes?
And I probably put 1 mole.
Hey, that's fine. You can put 1 mole above.
And then I'm going to put another 1 mole.
And then you put the grams. Yeah, or you can just do it in one step. You can shrink it and say, this many atoms of gold are going to be in 1 mole, and 1 mole of gold weighs how much? Yeah, I'm going to just put that here. 196 point what? That's it. 96. Does that make sense to you all what I did? I said, this many atoms, Avogadro's number is in 1 mole, but a mole weighs, I don't really want a mole. What do I need? Grams, right? And a mole weighs how much for gold? 196.966 because that's the mass.
What do I need to get gold?
Oh, because the question, if you see what the question says, right? It says, yeah, it says calculate the mass of 5 million atoms of gold. Does that make sense to you when I'm doing this? Okay. So I'm going to go back to that practice question. And so what should my answer be now? Well. I don't know if I said this, but this guy here, nobody measured him. So how a 6 people give back to a measurement? You think somebody actually comes to this many particles? How came up with it? So don't apply 6 6 to his number. Okay? So you always start with the number given in the problem, which is what? 5 million. How many 6 6 do you see in 5 million? So your final answer needs to have how many? 6 6. Yes, correct. So now I want you to do the math, which is simply, okay, last class when I was doing it for the other section, they were struggling on the math here. How do you do the math? 5 times 10 to the 6 times that number. Do it in steps if you calculate it. Doesn't understand the order. Yes? Do it in steps. But I think they were plugging it all in and getting, many got 10 to the negative 31. Anybody got 10 to the negative 31? You can easily if you don't follow the order. So the correct answer should be what? 2 times 10 to the negative 15 grams is the correct answer. Did you or did you not get it? Did not get it. Okay. You do, Michael? Do it again for me, please, and do it in steps. Can you do that? Times that stuff.
5 times 10 to the 6, 5 times 4 times 2 times negative.
No. This times that, and that whole thing divided by that.
Okay. 2 times 10 to the that's the one.
Yeah. This is the final answer. What I have here is the final answer. Yes, ma'am. I have my units. Does it make sense to you?
Wait, why is it number?
5. Notice how I wrote the 5 million? Did you get it, Rebecca?
I didn't know that.
Got it? Folks, please bring your calculators to class so that you're practicing with them. The negative? Yes, ma'am. What I want you to do for me is do that times that. So, can you give me the number, please, what you get? Okay, let me start a new page and do it there. Okay? So what's the answer? What do you get? 90 what? 98. Okay. Okay. 1, 2, 3, 4, 5. That's what you got. Divide this now by 6.022 times 10 to the 23. You have to do it in steps almost. You see what I mean? That's the problem. You do it almost steps. Okay, then is that what you got in the first step? So she's right. If you divide that by that, what do you get? I know the other side got it too. So now that number, I'd like you to put that in scientific notation first. Put that in scientific notation, assuming the decimal to be at the end. How many places do I have to move if the decimal is at the end? Okay, let's just assume the decimal over there. Okay, so 1, 2, do you see what I'm doing? 1, 2, 3, 4, 5, 6, 7, and good. So the answer would be 9.848 times 10 to the positive 8. Agree? Now divide that by 6.022 times 10 to the 23. What do you get? Then the calculator is messing you up because I'll tell you why. Think of this. Okay, I may have to just do this here, folks, just quickly, okay? 9.8, whatever. Times 10 to the 8 divided by 23, 6.02. Let's think about this. Yeah, 10 to the 8 divided by, if you were to just factor that, what would it be? 10 to the 8 minus 23, correct? And 9.8, you know, it's like 6.022 10, it will be close to like 2. Something. Do it. Yeah. Okay, just do for me this. Do 10 to the 8 divided by 10 to the 26. What do you get here as later? 10 to the 8 divided by 10 to the 26. Yes, when you multiply, you add exponents. When you divide, you simply get. See how your calculator screws you up on the top? Now, keep the 10 to the negative 15. Now do just this. 1.64. There we go. So what did you get? 1.64 times 10 to the negative 15, correct? Now 1.64 rounds to 2, and then the negative 15. Did you see how we did that and how we all got 10 to the negative 31? This is why I say calculators are not the best. Each of them, it truly has an evil mind. Makes you fail the test. It should, yeah, that's the thing. I think your calculators require parentheses. Okay, so that's a lesson we learned today. All right, so as we move on, you're going to see, if you get the whole concept, you've got chapter 4 down. And you're going to love it. If you don't, you're going to hate chapter 4. So that's why I need you to start loving it, because you know what? You don't have a choice. Because you're going to see the moles appear in every chapter from now on. 5 is all about the moles, 6 is all about the moles, 7 is, 8 is. So you might as well just get used to them all. Okay? So here is a little chart that you may not bring to the test, but it kind of sort of explains to you the point, right? If you're looking for particle atoms, use Avogadro's number, yes? If you're looking for mass instead, then you're going to use atomic mass, or what we call the molar mass, right? How to memorize this? It's not helpful. But the point is, if you're looking for particles, use Avogadro's number. If you're looking for mass, use the molar mass, or what we call the atomic mass. Okay? So let's see if you can do another problem for me before we move on. This is where I need you all to open your textbook and let's practice. And I want you to look at practice problem 4.3, everyone. Practice problem 4.3. On page 131. And really, I'm going to do it, but I want you to look at it and see if you even get it. I think chapter 4 for many people is, how do I even begin? I don't even get it. So I want you to overcome that barrier, okay? So look at the problem, because if I start doing it, you don't get the chance to learn. So practice problem 4.3. Ask yourself, do I even know where to start? How many moles of sodium are represented by that many number of atoms? Dimensional analysis is your friend. Yeah, I'm going to have to talk to Cyrus to make this all very smooth. And the pencil will not work. What happened, girls? You need the book? Let me read it. How many moles of sodium? How many moles of sodium are represented by 9.03 times 10 to the 23 atoms of sodium? Okay, sure. How many moles of sodium are represented by 9.03 times 10 to the 23 atoms of sodium? You get it? Good. I want you to ask yourself, do I know how to solve the problem? Yes, exactly. Always start with the beginning. Yes, exactly right. Nine point zero three times 10 to the 23 from the practice problem. No, practice problems if you look at green box. Then you'll respond to it.
Yeah.
That is the number of atoms or the number of moles. Also, we can be 9.03 times 10 to the 20. Calculate the number of moles of sodium in that many number of atoms. Okay, everybody has an idea of what they're doing here? Yes? What should I do next? I always start with what's given. Yes? So it seems to me that 6.022 times 10 to the 23 should go on the bottom. Seems to me that I can figure that much out. Everybody did that? Good. And what are you going to go? Where are we going to go? Moles. So now remember the definition. This many particles are in moles. Yes? So that's the thing about chemistry, is at least, the best part about it is it's logical. If you like logic, you will like chemistry. Yes? To cancel the atoms. Okay, folks, this is 80 atoms. You get it, right? Is it too terrible for you? Okay. To cancel the atoms, I always like to set my units. I insist that you show both for a reason. And those of us who didn't got things wrong. Don't tell me I didn't warn you. Yes, and the problem they do. They do. I wouldn't worry about plugging it all into calculators. If you see 10 to the 23, you can cancel. Make your life easy, right? Then all you have to do is divide that number by this, right? Because you're multiplying across. It's 1. I wouldn't worry about that.
But then are the numbers, you have to reduce the number 66?
Yes, ma'am. That would keep you, that would mean you would keep it at 366. Does that make sense? Yes, sir. Okay. So what answer did you get, Michael?
1.50.
There you go. 1.5. And think about it, okay, folks? Use logic. Yes, ma'am.
You're like around to 1.5 volts, you're going around to
Well, 9.03 has 3 digits. So I want to keep it at, right? So the first number we drop is the 4th digit. Let me just speak on this. Yeah. And remember, the moles will not be a ridiculous answer like 10 to the 23. You're not going to have that. The moles should be a very reasonable number, like 1.35, 2.2. It's not going to be 6,000 also. Okay? Keep in mind, moles is a smaller number. Like 2 dozen versus 2 dozen stands for 48. So see how the difference is because you're looking at particles versus dozens. So the unit mole is a smaller number. Did everybody get that, please? Oh, my apologies. Yes. 2 dozens is 24. Sorry. Okay, very good. Moving on. Everybody got the moles? You need more practice? Do it. One more maybe. Practice problem 4.4 for those who don't have the book. Write it down. What is the mass in grams? For those who have the book, I'm on page 131. At the very bottom of that page, what is the mass in grams of 3.50 moles of element helium? Okay. Once again, what is the mass in grams of 3.50 moles of the element helium? So I want you to go home by tonight, listen to this lecture, and tell me if it helps. We'll keep doing it every class, and the beauty is, I'll tell you where to go first.
I bet I'm learning some of the 19th century stuff.
You're right. Yes, see now that's the problem, right? With recording lectures, those who do it in other subjects, they students stop coming. That's why in science we don't do it. Now that's the other problem. Of course you have an attendance rate. So that's why we have the attendance rate. But if you did this, and you didn't have attendance mandatory, can you imagine how people would just stop coming? Well, I pretty much have to do it on there if you want one. Yeah, the board becomes, it's not a smart board. Yeah, I like to look at things on the class and practicing something. So that I want to make sure that it goes through. So would you have one? Yeah, 6 years, it's always one on these. Yeah, I mean, I have not hours and discretion to not it's not usually going to industrial. But I also want to give an ad.
We're not going to get asking for some
Okay, everyone, ready?
Oh yeah, you can if you want.
Did everybody get it? Let's see if you did it. So what am I going to start with? 3.50 moles, right? Now this problem, do you need to use Avogadro's number?
No.
Good, that's what I want to hear.
But you don't need to use Avogadro's number because it's independent atoms, right?
Exactly. So we're not just going to start using Avogadro's blindly. He's not involved in this problem. That's for sure. And you say, what do I just say, Maria? Complete the problem for me. What do I do? Where? Okay, which is what? 0.2 grams, and I got that from the periodic table, correct? And at the bottom, I'm going to say 1 mole of helium is that many grams. Everybody getting it? So see, folks, don't make this to be worse than it is. Very, very easy, the mole concept. Okay? Make sure you cancel units. The moles cancel with the moles, yes? The final answer, Karen, should be, what should my final units be? It's grams. You agree? Final unit should be grams, and what's the final answer? 14.0, did you get it? Very good. Excellent. Folks, I do want to say this in general to the class. Don't let the first test defeat you. Okay? You can still do very well. You have your 8 different applicants. I'm happy to help you. This is an attempt to help you. So you can go home and look at it any number of times if it's recorded. Okay, but I need you to help me because I will forget to press the record button and all that. It's a learning curve. And I'm going to have an applause. Okay, so we stop here. I see you back. Give me your input when I see you on Monday. Oh, right, Wednesday. Yeah, I want you to, can you see the recording button or no? Okay, so I'm going to say stop recording. I think that's it. Okay, see how it said stop? And Jacob said,